Okay, for number 3, the first thing I'd recommend to do is just kind of visualize this in polar form because they're asking for the fifth root of that number. And the problem with the fifth root of that number, there's going to be 5 of them, and that's going to be tough to compute if you don't know the polar form of it. So let's write this down over here. I'm going to say z is equal to, it looks like 0 minus 2i. Right, kind of visualize that for you in a complex plane. Again, this is the real part. This is the imaginary part. Looks relatively simple. And what I mean by that, there's no real part, but the imaginary part's going to be 2 down. So put this over here. I got the angle and the r now. The angle's going to be 3 pi over 2. That's called the argument. And the modulus r is going to be 2. So I can write z down. We're doing problem number 3, by the way. Is equal to, let's take a look at it. The r is 2. And then you're going to get cosine 3 pi over 2 plus I sine 3 pi over 2. Just for sake of convenience, I'm going to write this in degree mode because it's easier for me to do the arithmetic with degrees. Cosine 270 degrees plus I sine 270 degrees. Now you may have to go back and look at your notes, but I'm looking to get the fifth root of z, right? So the fifth root of z, there's going to be 5 of them, and I'm going to write the formula down for you. So the roots, wk, and there's going to be 5 of them, we'll go through that, is the nth root of r, we'll go through that. And then what's going to go over here is going to be cosine, we derived this in class by the way, theta plus 360 degrees k over n, boy, it's tough jamming that in there, plus I sine theta plus 360 degrees k over n. I'll close that out. I'm going to pull this up a little bit, and I'm going to start writing it down now. And to write that down, what I'm looking at a common computation, by the way. And that common computation is going to be this 270 is going to be put over here. So it's going to be 270 plus 360 degree k. I'll write that down for you. Oops, get back to black. So we're writing down the theta plus 360 degree k over n. Again, the theta is 270 degrees plus 360 degree k. And what's the n in this case over here? It's the fifth root, right? So it'd be 5. Right, I'm going to simplify that tiny little bit. We'll talk about the k's later, by the way. 5 into 270 is 54. Let me just make sure that's true. 250 and 20, yeah, 270. Plus 5 into 360 is going to be 72. Okay. All right. Since we're talking about a fifth root, the k is going to go from 0 to 1 to 2 to 3 to 4. It'll give us all 5 roots. So let's write it down. I'm going to write down in W notation, what was given to you in notes. WK would be equal to the fifth root. This is a principal root, but I want to write that down. I'm going to use that symbol to principal root. And what's the R? Well, it's 2. We'll check the key later. Cosine 54 degrees. We just computed that, by the way. Plus 72 degree K plus I sine. I know I'm going to run into this, and I'll just put that elsewhere later, okay? And sine of 54 degrees plus 72 degrees K, with the understanding that K could be 0, 1, 2, 3, or 4. And I'll just put a circle in this, indicating that's my final answer. And let's look at the K. What do you get over here? Seeing that. I'm seeing that. I'm seeing this, and I'm seeing that. Everything's been seen. That's good news. Thank you.